Typical civil structural engineering services for telecommunications site and tower development includes tower mapping, geotechnical investigation, engineering analysis and design, and construction. Each type of service generates engineering data and documents for the site and tower. The generated documents are saved to the site and tower information library. Here is a typical process of an engineering service project. Engineer starts from collecting needed project information through manual data retrieval from the library. Then, necessary engineering services will be ordered to obtain additional information needed for the current project. As the completion of the project, new documents will be added to the library. As more and more projects are completed, the documents for the site and tower piles up, higher and higher. Now, let's see the data communication interaction between different parties involved in the project. Tower climbers map the tower and prepare the mapping report, which is then sent to the structural engineers. The geotechnical contractor performs the geotechnical investigation and prepares the geotechnical report, which is sent to the structural engineers also. Meanwhile, the structural engineers go through the library to collect needed information, read through the tower mapping report and geotechnical report, perform the engineering tasks, generate the reports and drawings, which are sent to the construction workers. After the construction, the as-built documents are then sent back to engineer for checking and saved to the library for documentation. Such a process is characterized as people, documents, and people. What are the problems with current solution? First, redundancy. With current solution, the same procedure needs to be followed for each round of engineering service work. There are repetitive work of collecting project information, reading and interpreting the same data from the same documents for each round of work. Second, inconsistency. There are widely observed discrepancies between the interpretations of project information, such as tower structural modeling and loading data by different engineers. Third, low efficiency. Long deliverable turnaround time due to the repetitive work, which makes the tower asset less competitive in the fast-paced market. Here is the solution we propose for the problems, the STIM solution. STIM solution creates a digital representation of a site and tower. The site and tower information model using the data for a site and tower. Around the site and tower information model, all parties perform the engineering tasks and exchange the data through standardized interfaces. The communications between people and people is reduced and replaced with standardized input and output by forms and tables. The efficiency and accuracy of data communication is increased. Now, let's look at the new process of an engineering service project. The site and tower information model is initially created using the data from the documents saved at the site and tower information library. With the information model, for an engineering service project, any needed information can be automatically retrieved from the site and tower information model. Any new data will be added as updates to the information model through standardized portal interfaces. And all future projects would follow the same standardized procedure of auto data retrieval and site tower information model updating. The site and tower information model becomes a valuable asset to the site and tower. The process is characterized as people, model which is simple, straightforward, and efficient. Compared to traditional solution, the STIM solution is quality improving, cost saving, and value creating.